Hi, this is section 1.3. This is a lecture overview of this section here. And if you remember from 1.2, this is very similar. The only difference is that in this section, it's still quadratic equations we're still solving. But in this section, we're concentrating on number 3 down here in the types of solutions, the two distinct complex ones here. So when you have a quadratic equation, okay, you could get real like we did in 1.2, but you could also get complex. And so that this one only takes care of that. Now on this one, the complexes are going to happen when b squared minus 4ac turns out to be negative. And in that case, you'll get the complex number solutions. Because if you remember, the imaginary unit, which is I, is the square root of a -1. So if you ever get the square root of a -1, that's going to be with the I, just like what we talked about in class. So I gave you 3 examples. Now I want you to understand something. When we're looking for complex solutions, the solutions might have an I in it, which makes them definitely complex, but they also could have numbers without the I. And you're like, well, that's real. Well, yeah, it's technically real, but real numbers without an I are still complex because, for example, if you have 5, you can have 5 plus 0I. It's got an I in it, and it's still so, but it's going to be complex because every real number could also be considered a complex number, but not the other way around. So anyway, I gave you 3 examples. So x squared plus 2x plus 10. So in this case, a is 1, b is 2, and c is 10. So we use the quadratic formula. So x is the opposite of b, which is -2 plus or minus the square root of b squared, which is 4, minus 4 times a times c, which is 1 times 10, all over 2 times 1. So you get -2 plus or minus the square root. And this is going to be a -36 over 2 times 1. Now, once you look at this problem very closely, the square root of a -36 is the square root of 36 times the square root of -1. Square root of 36 is 6, and the square root of -1 is I. So the square root of -36 turns out to be plus or minus 6I. And then you got to clean up the rest of it. But you will get 2 complex solutions. Now, I'm not going to do the whole thing because this is just very, like I said, I keep saying this is just an overview of the lecture. And on this one, x to the 4th minus 16 equals 0. This one's going to be x squared plus 4 times x squared minus 4. It's a difference of squares. And then you set each factor equal to 0. Now this time I could actually use the quadratic formula again on both of these, but I'm going to cheat a little bit this time because there was another method called the square root method. I told you we weren't going to be using those very often, but this is the one time that I do like using this one. And what the square root method implies is just isolate the square and then take the square root of both sides. So you get x squared equals -4, and then x squared equals 4. You take the square root of both sides, so x equals plus or minus 2I. And on this one, x equals plus or minus 2 because the square root of 4 is 2. The reason there's a plus or minus because that's what the square root method works. So look in the book if you need a little bit more information on that one. And on example 3, you factor this one kind of like you did example 1 at the beginning. Well, we didn't factor this one, but we're going to factor this one. Then what we're going to do is what we did back in example 1. For example, if you factor this, it's x squared times x squared is x to the 4th, and then plus 8 and a plus 5. That gives me 40, and 8x squared plus 5x squared is 30x squared, 13x squared, sorry. So, and then we do the same thing we did back in example 2 here, x squared plus 8 equals 0, and x squared plus 5 equals 0, and then, yep, you're right, we're going to do the square root method again. So x squared equals -8, and x squared equals -5. And then I'll let you finish it up, but you take it just like you did back in example 2. So that's the quick overview.